In the annals of aviation history, a new era has dawned. Welcome to a world where cutting-edge technology meets boundless skies. Today, we unveil a marvel of modern engineering, a testament to human ingenuity and innovation. Ladies and gentlemen, prepare to witness the future of aerial dominance, the U.S. laser fighter jet. The military strength of any nation is heavily reliant on its military capabilities. For a significant period, the United States has held the position of a global power and has consistently invested considerable time and resources into the advancement of its military equipment. Particularly, the U.S. Air Force has continuously pushed the boundaries of military aviation and weaponry, setting the standard for other nations. Among the remarkable innovations introduced by the U.S. Air Force, the fly-by-wire fighter F-16 in 1978 and the development of unmanned aircraft, such as drones, stand out. However, the United States military now possesses a weapon that surpasses all previous groundbreaking advancements in warfare. This weapon is so powerful that it renders even fighter jets insignificant. It is known as the Tactical Ultra-Short Pulse Laser. Tactical ultra-short pulse lasers have a rich history dating back to the 1970s. Therefore, this new weapon is not a recent invention, but rather a significant upgrade from conventional laser weapons. The U.S. Air Force has successfully developed a next-generation, highly versatile weapon system capable of obliterating any obstacle in its path. Moreover, it can be seamlessly integrated into various military platforms or vehicles, making it accessible to both the Army and the Navy without requiring modifications. Despite being in the prototype phase, this weapon has already earned the top spot as the most remarkable advancement in advanced weaponry. It has proven its capabilities through successful field tests, and the U.S. military eagerly awaits the opportune moment to deploy this formidable weapon in the event of future conflicts. This laser technology is truly exceptional, and it is worth examining its unique features that set it apart from other weapons. The Tactical Ultra-Short Pulse Laser is a highly advanced weapon that emits an immensely powerful beam, surpassing the intensity of the sun by a factor of 1,000,000. Consequently, the beam emitted from this laser possesses an extraordinary level of heat. By utilizing a high-energy light beam, the Tactical Ultra-Short Pulse Laser is capable of delivering precise and forceful strikes to its intended target. In a matter of seconds, this weapon can effortlessly cut through metal, shatter glass, and even incapacitate electronic systems. Encased within a compact and portable frame, the Tactical Ultra-Short Pulse Laser, also known as TUSPL, may initially appear innocuous, resembling a camera or a large stage light. However, it is, in fact, an exceptionally advanced and groundbreaking laser. The deliberate compact design of this weapon allows for easy transportation by military personnel to the field. Despite its unassuming appearance, this laser possesses the ability to generate perilous ultra-short pulses directed towards its target. These pulses are so rapid and intense that they can instantaneously slice through steel and similar materials. Nevertheless, this weapon is not solely intended for destruction. It can also be employed for non-lethal warfare purposes, such as blinding enemy combatants or disabling electronic devices. One remarkable feature of this new laser, developed by the U.S. Air Force, is its remarkable speed. With a pulse duration ranging from femtoseconds to picoseconds, this laser is so swift that it can eliminate a target before it even comprehends what has occurred. On average, this laser releases an astounding 1,000,000 megawatts of energy in just 200 femtoseconds. To provide perspective, a femtosecond is equivalent to 1/4,000,000th of a second. Due to its rapid pulse duration and high beam intensity, this weapon is capable of cutting, welding, and even melting materials. In fact, the pulse laser is so precise that it can slice through materials without causing any heat damage to the surrounding areas. This particular property of the laser weapon is exceedingly rare, rendering it an ideal choice for a wide range of military applications, including target identification and instant point-and-kill capabilities. Unlike conventional lasers that emit a continuous beam of focused energy, the pulse laser employs ultra-fast light flashes to obliterate anything in its path. Upon firing, the laser's energy is absorbed by the targeted material, causing it to flare up and expand. The resulting expansion generates a massive shock wave throughout the material, accompanied by tiny explosions on the surface. The laser beam creates a clean and precise cut, making it a highly effective weapon for military purposes. However, the experts behind this superweapon believe that its usefulness extends far beyond the military, and that it has the potential to revolutionize a wide range of industries. Despite the laser's reputation for being a lethal weapon, it is likely to become more commonplace in everyday life, with potential applications in parking lots and home security systems. The laser's incredible power and speed are achieved through a special material that amplifies its energy, which is further boosted by an electrical current that causes it to emit photons. These photons are then passed through a series of mirrors and lenses that shape and focus the laser beam into the concentrated ultra-short pulse that is fired. In addition to its concentrated light beams, the ultra-short pulse laser also boasts advanced features such as adjustable pulse duration and energy levels. This signifies that it is possible to adjust the duration of the pulse to make it longer or shorter, as well as modify the intensity of the beam. These features may appear straightforward, but they are not commonly found in most lasers. The Tactical Ultra-Short Pulse Laser, TUSPL, represents a significant advancement in laser technology. In fact, it has been a long-standing goal of the Army to develop such a laser for several decades, but they have always encountered complications. However, this dream has finally become a reality, and they now possess a laser that can rapidly release energy in petawatts. Furthermore, the pulse laser possesses a unique capability to perform nonlinear optical processes, meaning it can interact with matter in distinctive ways. Unlike regular lasers that simply cut through or melt objects they are aimed at, this laser can generate high-energy photons and even create plasma from solid materials when adjusted to the appropriate setting. All of these functionalities make the TUSPL highly intriguing, and its full potential remains unknown as it undergoes further upgrades in the future. Experts have already predicted that the possibilities with this innovation could surpass our expectations, both in military applications and beyond. Field tests of the TUSPL have demonstrated its ability to neutralize enemy drones, disable enemy vehicles, intercept missiles, and instantly disrupt enemy communications. Currently, the laser has a range of 1 mile, but this is expected to increase in future upgrades. However, even this range is not a concern due to the laser's compatibility, as mentioned earlier. The ultra-short pulse laser can be mounted on any vehicle, aircraft, or ship, making it one of the most versatile military weapons ever created by mankind. Just imagine driving a military van through an enemy battalion with this weapon mounted on top of the vehicle. You would never have to worry about firing a single shot, as it can eliminate all targets within seconds. Truly, this tool has the potential to revolutionize the military and reshape defense systems as we currently know them. Prior to this, the only extraordinary next-level weaponry utilized by the U.S. military was hypersonic missiles. Hypersonic missiles are a specialized type of high-speed missile that can travel at a remarkable 5 times the speed of sound. This technological advancement has been a significant milestone in military weaponry. With a speed of over 1,500 meters per second, these missiles are virtually undetectable and have proven to be a game-changer in modern-day warfare. There are 2 primary variants of hypersonic missiles, the hypersonic glide vehicle and the hypersonic cruise missile. The glide vehicle is launched into the atmosphere from a rocket and then glides to its target, while the cruise missile is powered by high-speed air-breathing engines that propel it through the air until it reaches its intended destination. Both classes of hypersonic missiles are highly maneuverable and can maintain sustained hypersonic speeds. Due to their incredible speed and maneuverability, hypersonic missiles are exceptionally efficient at penetrating missile defense systems. However, the Tactical Ultra-Short Pulse Laser, TUSPL, has emerged as the next big thing in advanced weaponry. This laser uses high power fibers made from specially coated materials that amplify photons as they travel through them, making the laser beam even more powerful and precise. With a speed of over 300 million meters per second, the TUSPL laser beam is nearly impossible to evade, making it a very dangerous weapon. Despite its lethal capabilities, the same high-power fibers used in the TUSPL laser can be optimized to function as a non-lethal tool. For instance, it can be used to disable opponents in battle without causing harm. In conclusion, hypersonic missiles and the TUSPL laser are both significant advancements in military technology that have the potential to change the course of modern warfare. The TUSPL also showcases another advanced technology known as adaptive optics. This remarkable feature enables the laser to intelligently adjust its beam to counteract any distortions caused by atmospheric conditions. As the laser emits light, it becomes susceptible to the influence of atmospheric agents, which can potentially diminish its intensity over long distances. However, the TUSPOL has the capability to adapt to real-time conditions, ensuring that its beam remains focused and accurate regardless of atmospheric challenges. Furthermore, the ultra-short pulse laser is specifically designed for remote control and possesses the ability to modify its wavelength. This attribute holds significant importance as certain materials, referred to as blackbodies, absorb specific wavelengths. By altering its wavelength, the pulse laser becomes effective against a wide range of materials, even those that would typically reduce its beam power. Additionally, this laser can optimize its performance to suit different conditions. For instance, it can produce a continuous wavelength to counteract a blackbody's absorption spectrum or minimize the amount of energy absorbed by the atmosphere. These optimizations enable the TUSPOL to maintain a high power and intense beam over long distances without dissipating into the surrounding environment. Another distinguishing and potentially hazardous characteristic of this pulsed laser is its ability to be configured with multiple beam settings. The tactical ultra-short pulse laser can be programmed to emit multiple laser beams simultaneously, allowing it to target multiple threats concurrently. This extraordinary feature, combined with its speed and high power, establishes the TUSPOL as an unbeatable defense weapon. It is worth noting that the laser's accuracy remains unaffected when targeting multiple targets at once. Both the single and multi-beam modes operate with exceptional precision and accuracy. To enhance its capabilities further, the U.S. Air Force has also incorporated a beam sweep mode into this technology. The laser possesses the capability to swiftly scan a designated area and detect multiple targets or potential threats before neutralizing them. This attribute proves advantageous in situations where there are numerous threats, and it would be arduous for the laser operator to target each one expeditiously. The United States military experts have already verified that the tactical ultra-short pulse laser's multi-beam configurations and beam sweep mode make it an indispensable asset for the U.S. Air Force. Regarding control, the tactical ultra-short pulse laser employs advanced control systems to operate remotely and automatically in a complex setup of several components. One can control, target, and fire this weapon without even being present on the field. Despite being remotely controlled, every system functions optimally, and the laser operates at its peak performance. Typically, one can control all the systems in this laser from the comfort of their chair at the Air Force Base. The major systems in this laser include the Laser Energy Control System and the Beam Quality Control System. The Laser Energy Control System regulates the amount of energy transmitted through the laser, ensuring that the laser does not fire off an energy beam that is too high or too low. It also monitors the temperature of the laser to ensure that it is not too hot or too cold, as this can affect its performance. Given the impressive capabilities of the TUSPL, one may wonder if it has any weaknesses or shortcomings. There are a few, primarily that this weapon requires proper cooling. Like any other high-energy weapon that generates heat, the tactical ultra-short pulse laser necessitates adequate cooling. Otherwise, its heat can cause damage to the system or reduce its effectiveness in battle. Ideally, laser weapons are set to have a time duration for cooling. For instance, a laser weapon could have a firing time of 5 minutes and a cool-down time of 5 minutes. However, high-energy laser weapons are always pre-installed with internal cooling systems to ensure that they continue to fire short light pulses without any issues. The Tactical Ultra-Short Pulse Laser, TUSPL, incorporates robust and advanced cooling systems. The team of experts responsible for this tool has equipped it with a combination of air and liquid cooling technologies. These two cooling systems work simultaneously to effectively remove heat from the system. Air cooling is achieved through internal fans that circulate air around the laser component, while liquid cooling involves the use of a special coolant to transfer heat away from the laser. It is worth noting that this cooling system is unique, particularly for a high-energy, high-focus laser weapon. Typically, such weapons, also known as HL weapons, require chillers with high cooling capacity to dissipate the heat generated in the laser medium. The size, weight, and power of a high-energy laser system must always be matched with the capacity of the cooling chiller, which has posed a challenge in the design of advanced laser weapons. the demand for cooling chillers has constrained the ability to create portable laser weapons capable of releasing significant heat. However, the tactical ultra-short pulse laser has successfully addressed this long-standing problem in portable high-energy laser weapons for military applications. Its efficient and convenient cooling system has overcome the limitations of previous designs. Furthermore, the laser is capable of adjusting its cooling level based on environmental conditions. For example, in cold weather, the lower temperatures naturally cool the laser, reducing the need for extensive cooling. Conversely, during prolonged periods of rapid firing, the laser can increase its cooling level to match the heat it generates. In conclusion, the tactical ultra-short pulse laser represents a significant advancement in the development of portable high-energy laser weapons. Its innovative cooling system has resolved the challenges associated with cooling capacity and has paved the way for the deployment of such weapons on small weapon platforms. The auto-cooling technology incorporated in this laser enables it to operate at maximum efficiency at all times, contributing to energy conservation. The beam quality control system, as its name suggests, is responsible for maintaining the laser beam's quality. This system ensures that the beam remains focused and stable, capable of detecting even slight deviations and making real-time adjustments to restore the desired beam quality. The beam pointing control system is another crucial system in the TUSPL, ensuring that the laser beam is always directed toward the desired target. This system utilizes various sensors and algorithms to constantly detect and track the laser's position and orientation in real time, making necessary adjustments to keep it on target. Together, these three advanced control systems make the TUSPL exceptional in delivering highly focused, stable, and accurate laser beams. Currently, this tool serves as a key weapon in the U.S. Air Force's arsenal. Its significance lies not only in its effectiveness as an automated weapon, but also in its practicality and cost-effectiveness. Despite its long usable duration, this laser requires minimal maintenance. It can effectively neutralize missiles and fighter jets, and its capabilities are only expected to improve as it progresses from its prototype stage. Future advancements may include features such as invisible laser beams or integration into a robotic body, resembling the super beam of Iron Man. Regarding robots, it is worth noting that this text is written in a formal style and in English. When discussing the topic of robots and artificial intelligence, AI, in the context of the U.S. military, it is evident that significant investments are being made in order to develop more advanced methods of utilizing AI systems for defense and weaponry. It is worth noting that the United States is not the sole country pursuing this path, as other global powers are also diligently working towards integrating AI systems into their own weaponry. The potential of AI to revolutionize warfare surpasses even the most ambitious expectations of humanity. Thus far, the U.S. military has already deployed numerous autonomous and semi-autonomous systems, leaving us to ponder the extent to which these weapons may become even more formidable if the United States Air Force manages to harness the power of AI to its fullest potential. As technology continues to evolve, the possibilities are limitless, and we must remain vigilant for what may emerge as the next mega weapon in the U.S. military's arsenal. Thank you for watching this episode of Voyager. While you are still here, please take a moment to click on the video displayed on your screen for more high-quality content. Thank you so much for watching. I hope you found this video as enjoyable and informative as I did making it for you. If you want to be part of our community and never miss out on more great content like this, there's one simple thing you can do. Please hit that subscribe button below. It really means the world to us. By subscribing, you'll be the first to know about our latest videos and join a community of fellow enthusiasts who share your interests.